So today we're going to be looking at properties of waves. In this case we're going to be looking at the laws of reflection. I've got a plane mirror set up here. Plane in this case doesn't mean boring, plane actually means flat. And I've got a wee diagram in front of me where I've marked on a line at right angles to that, which is called the normal. We always measure angles for waves relative to the normal, which is always at right angles to the surface. When a wave hits a surface, we say that it is incident upon it. Incident just means to strike. And the angles I've got marked off on the diagram here are going to be called our angles of incidence. At the moment, there is no angle of incidence. It's 0 degrees because the light is passing straight along the normal. Remember, the normal is drawn at right angles to the surface of the mirror. If I now alter the angle of incidence to just make it 10 degrees, so there's now an angle of 10 degrees between the ray and the normal, we can see the reflected ray on the other side. And I'm going to mark on a point which allows me to measure the angle of reflection. I'm just going to keep moving it around now because I'll measure those angles later using a protractor. So if I increase the angle of incidence, we see that the angle of reflection also increases. I've now got the protractor in place. I've got the wee sort of crosshair in the middle of the protractor lined up where the normal meets the mirror, and I'm now looking at the rays that I drew on the reflected side, and I can see that the angles are pretty much the same as we would have for the angles of incidence. This one here actually measures exactly 10 degrees. And if I do the same for the other ones, we get